all the question we could we should be able to answer them all, but I did not want to put any pressure on some difficult questions. So I said, well, make it a practice problem. So we're gonna go through the exam when we, probably get to the end of the week or next week. We're gonna review it because I want us to be more productive. We are back fresh, so we wanna learn new knowledge, right? But on the agenda, right, a midterm one review is there. We will do it, okay? So, and then what's the next thing here for us? What else we got done? Assignment 3, we also got done, right? Did everybody get assignment 3 grade? Everybody? Yes? Yes? Okay. We did very, very well. And I, upgraded our assignment 2 score. If we score higher on assignment 3, I hope that helped. I hope we all got our grades. Yeah, upgrades. So that's another item that I did. What else did I do on the weekend for us? Oh, here we go. Presentation, right? So we have a classmate in the tag and toe section side up and work with the grader to have their solution evaluated. So the grader said yes, and this time I will take a look at their solution as well. Early this morning, a classmate from our section also emailed me and signed up, and I already connect the classmate with the grader to evaluate the solution. So that's another item that we got done during the break. So I've been working during the break for us. And next, we have assignment 4 and assignment 4 preparation. Well, I got the order reversed here. Assignment 4 preparation first, and then assignment 4, right? How about 15 seconds? Can we please, take a look at assignment 4 preparation and assignment 4? And then I want to, discuss a little bit quickly. And then you read more, and then we talk more about them again on Wednesday. Okay, 15 seconds, please. Can you please pull out, see what the assignment is about? Any question, any burning question for me? So we know what to expect, right? And then we continue with our material. Last time, we stopped on line number 326, package number 5. So we also want to get package number 5 out, everybody. Yes. All right. It's 8:04. Oh, that's a good 4 minutes of recap. Any question, everyone? Any question? Any question? Any questions so far? So here we go. Assignment 4, where are you? Oh, wait. Don't tell me that I did not put assignment 4 here. Assignment 4. Here we go. Clean. Assignment 4. Here we go. Let's get back here. Assignment here. Assignment 4 preparation. There you go. All right. So a fire assignment 4 preparation, everybody. Okay. So the idea here is this. We have assignment 4 preparation 25 point, right? And assignment 4, how many points itself, everybody? Who read the assignment? Who read the assignment, please? Vaya, good morning. Thank you so much, right? And we have assignment 4 itself is, here we go. 75 points. Okay, so the two assignments together, going to make 100 points, right? So this assignment used to be 100 points, right? So this assignment 4 used to be assignment number 4. So it used to be 100 points, everybody. But now we break it down to 2. We have assignment 4 preparation, right? And assignment 4. The reason is this. In assignment 4, we are using 2 important concepts, old concept, right? Number 1 is recursion, and number 2 is a link back. And those are the 2 concepts that, very fundamental. We should learn in the first 4 weeks in 220, data structure. But some classmates never heard of them, because, any reason. So I want to make sure that, we have a chance to help each other or to review early and also get credit for that. So that is 25 points, right? So this is a link back, right? Link back is an implementation of the linked list, okay? And also in assignment 4, we are going to learn new modern concept in C++, which is smart pointer. So those are 3 main points of this assignment. So now for these 2, right? And to understand assignment 4, I want us to work with, I gave us all the materials, right? I gave us all the materials, and I want us to work with 4 other classmates to help each other understand the assignment and to, succeed. And this is the last big assignment before the end of the semester. Assignment 5 is pretty small, very small one, very easy. We can get it done within 30 minutes. So and this one, we want to also make some friends, with classmates. So it's perfect to have a group work here, 25 points. And then when we come to the 75 point, I will talk about it. So now for this 25 points, right? I gave us the about here. Okay. The goal here is this. Number 1, when we work with our team, that means we are practicing our teamwork skill, right? And we're going to talk more about problem solving in the last 15 minutes of the lecture today. And this is going to make more sense to all of us. And the second goal of this assignment is to help, each other succeed with assignment 4. That means we're going to read the team, the 5 classmates, going to read assignment 4 together and ask and answer each other's questions, what is this assignment is about. It's okay to talk about the approaches, right? But we are not going to share the answer. So now, here we go. The 2 main concepts here, the link back and the recursive function, okay? So recursive is an old topic. Link back is an old topic, but we will talk about them again in class. But we're going to look at them through the lens of, C++, language rather than Java, okay? How come there's a pointer on the screen here? Oh, okay, that's my computer. And then we should, this is important, everybody, please make sure we mark this. We should start both 2 assignments at the same time, okay? We should start both 2 assignments at the same time. Who is plussing so much? C++? So here we go. Part A of assignment is team building, right? Basically, we are doing the basic step to build a team. And the second part of assignment is to, have the team meeting. So the team meeting gonna, get us 20 points, and the team building is 5 points. So I gave us all the steps here. Basically, I created a forum for us, right? Where we can post a message or we can use any available communication channel, right? And to look for 5 teammates, okay? And then we send our team roster to the grader to make sure that we all, get lined up here, right? And then we communicate with each other and start to have at least 3 meetings, okay? At least 3 meetings. So that gets us 5 points. In the second part, right? I made a Zoom 3, right? 24/7 open space for us if we need to use it. But I'm sure that we have, Discord channel, anything that you want to use. I provided us with all the materials, okay, and even more on the the file manager, right? I provided us with the packages, the diagram, and the recursion and the solution to the recursion problem for us to do the review with each other. So now it's important that we submit the meeting summaries to the grader in order to get credit, right? For each meeting, make sure that we have a quick summary. Most importantly, okay, here we go. Most important part is that in each meeting, right? In each meeting, each team member must ask 5 questions. There we go. This is how we learn. So each team member gonna take turn and ask 5 questions, and the team gonna answer all those 5 questions, okay, and discuss and make sure that we write out our question and answer so that our grader have some kind of quantitative way of grading how we did with our team, because they cannot attend our meetings, right? Too many meetings to attend. So we include all of those 5 question and answer, okay? And that's also help us, prepare for assignment 4. Include that in the assignment report. And the last part is what? The last part is evaluation of the team performance. So we put all the team members' name here, right? And we give them, our own evaluation of how many points for their teamwork, and then any comment that we have for them. All right. So that's going to help the grader grade their performance as well. Reminder that we want to do assignment 4 and assignment 4 preparation at the same time. Okay. All right. Assignment 4 preparation is due April 14, but we want to start right now, today, right after class. Because if we sign up, if we, for example, we form the team late, right? This part gonna take a lot of time, everybody. Okay. If we form the team late, there will be no more teammate, right? And it's very difficult to schedule a time to meet. So start early, and get it done. That's what I would say. Any question here, everybody? And of course, I give you time to read the assignment, and until the assignment's done, we're going to continue talking about it. Okay. So let me show you assignment 4. So this is assignment 4. This is more important here. So assignment 4 is what we aim to, for here, right? So we are doing everything for assignment 4. Assignment 4 is 75 points. In assignment 4, part A is about smart pointers. And this is what we're going to learn in package number 9, coming very soon, right? And then when we start our meetings, everybody, okay? When we start our meeting for assignment 4 preparation, we can start doing this right away. We can start doing this right away. So part B, we have all the knowledge to start right now, okay? And then after we done part B, which is 40 points, a very big part of the assignment, that's when we can get back to part A. So let me give you the orders here, everybody, okay? So you want to do part B first, and then we do part A, right? And then we do part C, because part C is basically the combination of A and B. So C is equal to A plus B. So we learned the, linked list, link back into 20. And now we just want to make it smart, okay? Turn it into the smarter version by using smart pointers. And then part D, you can start anytime. Part D is about showing our creativity. After, we learn more about problem solving, we're going to learn how to be creative as well. I have some material from my master in finance, and I want to share with all of us, okay? So why did I not put, part A after part B then, in this order? Just because I want to put link back, right? Or everything related to link back together, okay? So we want to organize part B and part C together. All right, so that's the assignment, okay? Please get things set up, right? Download the code, put that in Visual Studio or your favorite IDE, and start the teamwork. And any question, we will talk more about this assignment on Wednesday, okay? Are we all good, everybody? Yes? Yes, just for a quick, idea of what this is about, all right? So now let's open package number 5, please, okay? And we're gonna discuss package number 5 until 8:30 or 8:35, and then we talk about problem solving, all right? So now, first round of discussion for our section here. Let me put a tick mark here. I don't want to lose track of things. We talk about this assignment prep, and we talk about this assignment. All right, 326. All right, 326. Here we go. 326. Where are you? 326. Wow. Welcome to week number 10, everybody. Where did time go? Here we go. Package number 5, 326. Okay, so where was our conversation last time, everyone? I remember Jasmine was talking about the green and the red color, right? Kind of get us a little bit at the end. So again, so let's do a quick check, make sure we understand everything. what does L value reference everybody? L value reference what? Good morning. What does it reference? So last time we finished until 2:26, right? And the last several points that, so it references a non-temporary, a permanent object. So an L value reference should reference an L value. Are we all good? Yep. We should reference an L value. So my next question is that, can a L value reference an R value? Can it reference an R value or not? No, right? Okay, very good. Good morning, Mimi. Okay, my next question for us is this. Is L value reference a L value? Is L value reference a L value? Is it an L value? We have a reference, right? That is referencing a L value. Question is this. Is this reference is being an L value itself? Absolutely yes, right? Because it has a name, right? Any reference should have a name. Are we all good here? So to be a reference, it must have a name. It has a name. It has an ID, right? It has an ID, then, you know, it is an L value. Okay, let's make it a little bit harder here to start a good, you know, week 10 here. Last question. Yeah, last question. An R value reference, can it be an L value or not? An R value reference, is it an L value? So we have an R value reference that referencing an R value. Then is it an L value or not? Is it an L value? The question is, the answer is the same, right? Yes, it is a reference. Doesn't matter if it's an L value or an R value reference. It has a name. It has an identity. So it is an L value. Are we all good now, everybody? It's okay to say, the spring break was too joyful, I forgot. Can you explain more? Or can we move on here? And of course, when we move on, we're going to continue to review anyway. Are we all good with this, everyone? Or no? Okay, let me explain more, right? All right. So now, here we go. The best place to explain for you is right here. So here we go. Online number 313, right? Online number 313. Okay, I'm going to be careful about the colors that I use now. Online number 313, we are having in 210. Let's just look at it as 210. We are having a variable that is equal to this value. And then we said, I want to reference that variable. So now I have reference string, right? That is referencing a value that is existing and has a name. So on line number 314, reference string is what, everybody? Is this an L or an R value? Is this an L or R value? It is a, first of all, what is it first? What is this first? It is a L value reference, right? Because it's referencing a L value. Are we all good now? And it is a L value reference, so it is an L value. Can I have a confirmation that we are good here, please, before we move on here? Yep. I talked with a classmate over the spring break, everyone, who had an interview, and they did talk about both L value, R value, and smart pointer. Yeah, in her interview. So, you know, that's inspiration for you here. Okay, so now next thing, right? Next thing we talk about this. On line number 323, on the right side, we have an R value, and we are creating, I got asked about pointer too in an interview. Oh, that's great. Did you do the midterm before that? Yes. I hope you did, Chip. So on line number 323, right? Here we go. We have an R value reference, right? And we have a double ampersand here. So the R value reference is referencing an R value. Are we all good here, everyone? On line number 223, before I ask the questions again. Yeah. So we have a literal, right, string on the right side, and we have an R value reference to reference an R value. But now this R value reference is having a name itself, right? So it is an L value. Does it make sense here? Can I have a confirmation that we got this point? And this is where it was a little bit confusing for all of us, right? Are we all good? Yeah. So it is an R value reference. It has an ID. It has a name. So it is an L value. That's what we got last time. All right. Welcome back. So now line number 327. On line number 327 to line number 332. Let's take about 5 seconds. Okay. Make our observation, everybody. You're very welcome, Rita, and thank you for your question. After a break, we all need some refreshment, right? So now on line number 327 to line number 332. 5 seconds, okay? We are seeing something new in here, something that very interesting, something which is a heart, which is a core, which is the main substance of the modern C++. Okay, so please read and give some observation. That's right, the move. The move, everyone. Move is one of the most important elements in modern C++. In the second half of our semester, in almost every meeting, we're going to talk about move. And this is the first time we see move, okay? So now, on line number 327, everyone, you will see that how much you just learned after half a page of code here, right, on this page. And now it should be easy for us now. On line number 327, we are seeing this. We are seeing an L value referencing an R value, right? Because that L value is an R value reference. Did my statement make sense to you now? Does it make total sense now? Yeah. 1 or 2 lectures before I would be like, are you talking Greek or Chinese or something, right? Let me repeat here. On line number 327, we are having an L value that is referencing an R value because that L value is actually a R value reference. Can I have a confirmation that it makes sense to us, please? Does it make sense to you now? Yes? So it's just a summary of everything that happened before that, okay? We keep building on top of what we learned. So now when we see out, everybody, this is lovely. This is lovely. So when we are seeing out this, we are seeing out the value of M, the address of M, the size of M. So all 3 things here are very interesting. Number 1, the value of M is Mickey. The address of M is ending 9E4. The size of M, this is very interesting, 28. Okay. Sometimes people are going to ask you why 28. And this is going to take several classes to understand, everyone. Not just, I mean courses, not just class meeting. But for now, I want you to write out that this number 28 for the size of the string is only for Visual Studio, Microsoft Visual Studio. If we run this on other, system using other compiler and IDE, we will get a different number. Maybe by the end of the semester, when we learn more, I will explain to you why. Okay. So now, on line number 333, on line number 333, if we're trying to create an R value reference, a to reference M, right? It's gonna fail because of what, everybody? Why is this line fail? You go to an interview and they give you this line and they say why it failed. Too easy for you now. What is the answer, please? Why is this thing fail?
Is it because we have a R value reference, or sorry, a L value reference trying to reference a L value?
That's right. Because thank you, Jasmine. Welcome back. Because we are having a L value on the right side, and we are trying to make an R value reference to reference an L value. Are we all good now, everyone? Right? We can only R value reference an R value. On line number 331, we are having the fix for line number 330. Okay, the mighty powerful move function. All right, so here we go, is the move function. So what is the move doing here, everyone? A move making 330 works. What did move do? What did move do? Any guess?
Can I guess? I can try.
Oh, go ahead, Chip. Welcome back.
I'm guessing that it moved it from an L value to an R value.
Wonderful. That's it. You should get a lottery. So it moved, right? For a split second, it moved an L value, okay, the state of the variable from an L value into an R value, just so that we can create a reference. And then after that, M, gonna just come back, being an L value still. Do we understand what's going on here, everybody? This is just an introduction to move. We're gonna learn a lot more about move. We're gonna learn the whole second half of semester about move. So for now, what we want to write down on line number 331 is this. On line number 331, move is changing, right? Move is converting. The main keyword for this is this. Move is converting M, okay, into an R value for that split seconds, for that statement only, not to be stored. It is stored if we what is it in this case, Jasmine, that you're asking? Where is it stored?
The converted M.
So thinking about a switch, Jasmine and everybody, okay? So we are having M here, right? Remember memory, right? We don't look at memory as a box only. This is a memory slot. And we always have metadata, right? The data that describe the data. So let's say that, this M here is actually a L value. So for a second, we convert it, or we just, kind of flip the switch and say, well, for a split second, I want it to be an R value. It did not change anything about the actual value of M or the storage or the location of M. Very good question. Does it make sense to you, Jasmine? It's like casting. It's not like casting. It's not like casting. It's not like casting. Yeah, it's not like casting. It's really about just changing the state of the access. Okay, so here, let me give you this keyword. It makes more sense to you here. So when we are talking about casting, Jasmine, we are talking about, working with the content of the object, working with the actual value of the object. When we are talking about the L and R value, we are talking about, flipping the switch, right? Changing the state of the access for a split second. That's what is going on here. All right. Does it make sense to everyone here? Does it make sense? If it makes about 50%, of the, if it makes sense about half cent to you, it's okay. Then we're gonna move on and we're gonna learn a lot more about this. Yeah. How we doing, everyone? We just need to write out very briefly here is that it's converting an L value into an R value for us. And move can also convert from R to L. Are we all good here? Yes. Yes. And here we go. If we look more here, the next line, we're going to see how it works right away. On line number 32, right? At this moment, we are printing out string 5, right? Address of 5 and the size of 5. We see that we are getting the exact value. Here we go. Mickey, right? Memory address is still the same and size is still the same. And the reason here is this. We just created a reference to an existing object that has a name. And a reference is, whenever we say string 5, we means M. That's why they should have the same value. And because it is a reference, so it should share the same memory address with the object. And because it's the same object, so it should have the same size. Last question here. Looking at this code, right? Who can tell if string number 5 is being a pointer style, right? A reference or an alias style reference? If we remember this topic, everyone, is this a pointer style or is a reference style or is an alias style reference? It is a, what's the difference between alias style and pointer style reference, everyone?
A pointer style reference creates a new object inside main.
The other way around, right?
Okay.
So let's think about, thank you though. This is package number 3 and this is package number 5. Package number 3, we say this. We are having an object stored in a memory slot. In that memory slot, there's a lookup table and we can have as many references as we want. In one scope, right? We call that the alias style. Are we all good? So now in package number 5, that's when we talk about, we have a reference, right? Coming from another scope. Remember this story, everyone? Yes? So now C++ hide the implementation of this pointer that is pointing, to this reference. And this reference is actually what? It is a reference to an object, right? And in the same memory location from a lookup table, we can have as many references as we want. So this is what we call a pointer style reference. Remember this conversation, everyone, when we talk about swap 2 and swap 3, and we had a chance to revisit that in our midterm, right? And we're going to review our midterm as well. Okay. Did we understand this, everyone? Yes. Yes. All right. Next thing. So now let's look at the function on line number 338. This is a return value function. Exactly. Pointer style reference go across scope and alias style is the same scope. So in this example here, let's look at this. 1, 2, 3, 4, and 5. So what I mean by that? So we see that we are making 5 calls, right, to return value. We are making 5 calls to return value. And we see that value is returning CS. And CS is an integer. And now we are receiving CS. We see that on line number 349, it failed. We need to explain why it failed. Are we all good? Yeah. And then we need to understand how it is different. Over here, we are receiving as an integer. Here it failed for line number 2 for the second call. And then here is 351. we are creating an L value reference. 354 is R value, and here's another R value. What really happening? How about 5 seconds? Do we understand the syntax and what happened, you know, in the background, everyone, to the memory level here? I gave us the more references here on the right side that can help us understand what's happening. Okay, and then 5 seconds. Let's do some observation together. Returning a value. I'm going to write this down. Returning a value. We want to look at this, everyone. Returning a value. So what is the best way to learn this? The best way to learn this is this. Last time we talked about in C++, when we make a function call, the ways that we receive a value matters. And now we're talking about L and R value. Because we are talking about L and R value, we want to pay attention to the keyword value. So now if we are returning a value, right, is it going to be received, store, reference, okay, use, whatever you want to think of, as an L value or an R value, right? And what's going to involve in there? That's what we need to find out. And then that's what makes it really interesting here. So now for case number 1, on line number 346, right? When we say integer x equal to return value, what are we doing, everybody? What are we doing here?
We're storing an L value inside of an L value reference.
We are storing. Okay, let's take a step back here. On line number 341, when we say we are returning a value, are we returning CS or we are returning the literal value from that CS is holding? How about that? Are we really returning CS, right? Or we are returning 340? 340, there we go. So when we talk about value here, we're talking about 340. Are we all good now, everyone? This is very interesting, okay? So from the scope of the function, we are returning a value. So now on the right side, we are having an R value or L value, everyone, being returned here. It is we are returning an R value, right? A literal value. Does it make sense here? So on the left side here, when we say integer x1 equal to R value, we are actually creating an R value reference in order to receive that value, right? That's really what's happening here. Why is it R value but not L value? Because we are returning by value. Like Danielle, you know, giving me a pen, right? Or last time our classmate Joe in section tax said it's like food delivery, you know. Or in our class we called it a deep value, a deep copy. Does it make sense, everyone? Does it make sense here? This is we are receiving a deep copy, right? We are storing a deep copy R value into this variable. Does it make sense? Does it have anything to do with the CS variable, everybody? Does it have anything to do with it? After this copy, after this storage? No, right? So one keyword we want to put here is that it is a deep copy. It's a deep copy. This is why knowing deep copy make it much easier to us. There you go. So Daniel got it, right? Welcome back. Thank you so much. Okay. So now why don't we need the ampersand? We talked about it last time. right? We talk about the old C++ and modern C++, remember? And we're gonna explain it again when we get to 4 and 5. All right, are we all good? Understanding that number one, we are storing a deep copy, everybody. Can I have a confirmation here? Yes, before we move to number two. All right, so now we get to number two, right? When we get to number two, why doesn't it work, everybody? Why on number two, it doesn't work? Why number two would not work? Okay, so Jeep said that we are trying to create an L value reference, right? We are trying to create an L value reference to an R value. That's why it did not work, right? L value reference to an R value. That's why it's not work. It is true. It is true, but it is a little bit more complicated than that. Because in this case here, rather than just a literal value, we are actually returning it from a function call, right? Return my value. So we are giving the value to the x2, right? We are giving the value to the x2. And that means x2 should be able to reference the value, but there's something missing here. And this whole thing, you know, don't really make much sense, but let's try to make a little bit of sense to this. And this is the reason why, you know, they are redoing all of this in C++, in modern C++. And this also answers the question, why did not we do the double ampersand? Okay, 5 seconds, everyone. What is going on here?
Is it that we are trying to take the value of CS and create a reference to it, but because it doesn't exist anywhere, you can't do that?
So when we are returning, there's a transferring of the value from one memory location to another location, right? So that's what it means by returning. This is why I written down, you know, literally. Okay, that's right, Danielle. It's trying to store the value in a memory address. That's what it means by returning. And from position, right? From the perspective from x2, we are saying what? We are receiving. Does it make sense, everybody? Or we are storing the value given to us, right? Right? Does it make sense now? So the function is giving us the value and telling us that you can store this. I'm giving it to you. However, it is giving an R value. When it is an R value, that means what? When it is an R value, that means we cannot change it because it's just a literal value. It has no name. It has no identity. We cannot change it, right? And on the left side here, everyone, we are asking that we want the full type to this reference. We want the control, access and control to the value that being passed to us. That's why we did not have a contract. Are we all good here, everybody? Yeah. On the right side, right, we are returning an R value. And when it is an R value, means that we can only access it. We cannot change it because it has no identity. Okay. It has no identity. It has no name. It has no owner. We cannot change it. So in order to fix this problem, in the traditional C++, right, they have no other options, everybody, but just to add a keyword constant to the front. And then they call this the binding, okay? This is a fancy keyword binding. And people talk about, but, you know, few people really explain what it means. So binding means this. Binding means the process of receiving a value that being returned from a function. In this case, is from the function on the right side, for function call, and now store it into x2. Okay, store it into x2. But the problem here is that it is being returned by value, and it is returning by an R value. If that make it easier for you here, everybody, is returning by R value. And R value means it's not an L value. That means it doesn't have an identity. That means you cannot change it. If you cannot change it, you cannot ask for full type integer. You have to make it constant. And that's why 3 is being the solution for 2 by adding the constant in front of it. And it works. It works, but there's a problem here. It worked, but we will not be able to change x3 from now on, right? So we receive, receive the value, we store in x3, we want to have an integer, but we cannot change it. The only way to use this integer now is probably to create x6 and say x6, integer x6 equal to x3. And now we can change x6 if we want to. Are we okay with this conversation, everybody? Can I have a confirmation here? Yes? Yes? Right? So this is why, if we put all of this together, everyone, now we start to see that modern C++ makes sense. In order to receive the R value being returned from the function, all we need to do is to create an R value reference. When we create an R value reference, now x4 and x5, right? x4 and x5 both have access and control to the value that they are storing. This is a deep discussion here, everyone. Do you understand this, everybody? And next time we're going to review this as well. Yeah. Next time we're going to review is you understand this? Yeah. I planned to talk about problem solving, but let me explain this well to you so that next time we can talk about problem solving then. Any question here, please? Any question? If you understand this, it makes my day. Next time we're going to go to problem solving.
Just a clarifying question.
Mm-hmm.
If we write into x6 equals x3, we can remove const, right?
So if we put, x6 equal to x3, right? We are just copying the value of let's say, what are we returning? 340, right? So x6 now equal to 340. So we are just copying the value.
And then we can write like an R value reference, an L value reference to x6 without a problem.
No problem. We can do anything to x6.
Okay.
Right? So x6, so be careful here, because when we say integer x6 equal to x3, right? What are we doing here? We are not creating an L value reference. We are creating an L value. We are creating a deep copy, exactly. So after that, we can do anything with x6. Okay, I know. Going back and forth between a reference and just a copy, the deep copy that Danielle is saying, right? If we are not careful, we get very confusing. But the moment Danielle said deep copy, probably Jasmine understood it, and everyone. Great question. Are we all good now, everybody? Do we understand what's going on here? Yes? Yes? All right. I know. It was exciting, but it's never easy to come back, right? On Wednesday, we're going to talk about this again, okay? And any question about assignment 4 prep or assignment 4 itself, please bring on Wednesday. Welcome back, everybody. Thank you very much. Next time, we're going to talk about problem solving. Yeah. Have a nice day. Thank you. Thank you. Welcome back. Thank you.